Alright, welcome back, generals, to another Let's Fix Generals 0 Hour to make the best game ever. Okay, so we have a bunch of things to test in this session. There's some spam by Inhibition, aka Baptista. Okay, what does it say? Unfortunately, it seems that it does rely on dwarf data. Uh-oh. Debug number of symbols. Dynamic symbols 144. Stubs. Constructors 0. Destructors 1. CPP symbols 5. Yeah, that's not much. Raw symbols. Game center, deferred imitation, operator delete, trampoline. Yeah, trampoline is probably just a function which does a jump, I guess. Type compiler, 1 symbols, undefined, sample. Yeah, that's not much. I was able to play around with a Python script and get some basic info out, but I don't know if any of it is helpful. This runs if you have Python 3.9 and the LLDB module install. Section types. Zero. Found 0 classes. That's not much. Can you test it, please? Can you test it? Yeah. So this information indeed doesn't look all that useful. That's LLDB info does not look that useful indeed. Okay, good. So so what we want to do here, oops, I didn't mean to do that. So let's open llvm here. llvm llvm, it was object dump, right? llvm object dump. There we go. Okay, let's open my command prompt. Then we do, well, first we need to change our work directory. So we go to projects, assembly Armada, MachO analyze data. We do cdd and that, and then we do this guy. llvm minus object dump and minus help, and let's go. Let's see what we can do here. Maybe make it extra wide here, extra big. Good. So let's see. So there is display all available header information and the symbol table. So I guess we just try different things. So minus all minus headers. Let's see, and then ZH, right? Oof, okay, let's dump it into a file. So that will be llvm minus object dump minus all minus headers .txt. Yeah? There we go. Okay. Then let's go with help again. What else? Target arc to disassemble for. Disassemble for. Archive headers. Display archive header information. Okay, let's see that. Minus archive minus headers. This. Oh shit. Archive headers. There we go. Let's take a look. Okay, so archive headers is empty. All headers. Let's see what is in here. It's pretty much a lot of information in there. Okay, so it does. Oh. Okay. Now that looks interesting. That does look interesting. This looks really interesting here, because we have a function here at the bottom, and I assume that this is contained in this CPP file, and this CPP file includes these things? Maybe? Not sure. But then why does it list the same file again up here? Not sure. I don't understand this relationship, but I assume that this function is contained in this CPP file, which is an awesome information. But how this came to be, I don't understand. Drawable init static images. It also says CPP here, but the one right above is a header file, and ASCII string certainly won't contain this function. Huh. I wonder how these things work, but I mean, it's in super close proximity. It's here drawable CPP, and here's drawable class. So it's certainly inside this drawable CPP, right? Let's look at some more samples. Here, countermeasures behavior. Looks like a constructor or something. And it's inside this countermeasures behavior CPP. Yeah. So there certainly is a relationship. But maybe the topmost here, the topmost one. Let's see. Maybe, yeah. So the topmost one contains an include to this, but then why does it? I don't understand. Why is there another record for this, and then another one, and then another one? Why is that? I don't understand. Strange, very strange. Okay, but this is this looks really, really good. This looks really good. What do we have here? Oof. I think UND probably means undefined. Undefined. Attack priority info. Thing template. Inside script engine. Yeah, maybe. Attack priority info. Yeah. Vector TCC. TCC. That's also weird. macOS. Okay, I don't know how it's there. Okay, but this looks really, really nice. I don't know how they got this info, but I mean, this is llvm, so yeah. What do we have here? Oof. Global I. Sub-objects upgrade module data. This here looks to me like this is the size of this thing. Maybe. Here, 1 dB. Upgrade implementation. 1 dB is a byte size of this function, maybe? Yeah. I don't know. What could this be then? 41, 46, 40, 60. Data field path. I don't know. Well, it could be the byte size that this, so data field path I think is an array, and maybe each array element then takes, so it has this amount of array elements, and the elements take this amount of bytes maybe, and starting from this address, maybe. Yeah, maybe. And it's inside this function maybe. Yeah. Poof. Okay, but this looks really, really promising. There's some nice information here. Okay, can we maybe combine this? So this was dump all headers, right? All headers. Let's rename this. All headers. No. Can we demangle the names in there? Let me see. Demangle symbol names. Yeah, let's try this. So we try here all headers minus demangle. Let's see. And then we say minus minus demangle. Yeah. Let's see. Demangle. Okay. Let's see if that works. Yeah, it's a bit larger. Let's see. That is demangled. Okay. Let's see if it's fully demangled. So even the F is gone. F. Match case. Oof. It's V. Oof. I don't know. Let's just look through here. String literal. Coalesce data. Hidden. What is this? Pause operator new. String. Literal. Okay. vtable. Oops. Yeah. What is this dollar symbol here? Worker shoot template dollar and then a number. I don't know. Okay, so it did not demangle this one here. So llvm has some troubles, but we can manually fix it. Actually, we already did that, so it's not a problem. Okay, yeah, but this shouldn't be a problem. We can manually patch that. Okay, we also have here O file. This one is not demangled. Okay, we don't fully understand all the things here. I don't know what this means here, this L and this O. F is probably a function. O object, I don't know. data. Game state. ASCII string. Get map leaf. Game state. Okay. What is this here? The game state G. And then save file UF, save game extension, 0 name only. Okay, let's see what else we can do here. So archive headers, so all headers display all available header information. Symbol table. Build ID. No. Debug was debug info. Sorry. Disassemble all sections. Yeah. Let's see what this gives. Let's do, what was it? Disassemble all. Right. Let's do disassemble minus all and demangle. Disassemble minus all demangle.txt. llvm-objdump disassemble all demangle. Error. Unable to get targets. Oof. Get targets. Unable to get targets. See version and triple version. Display the version of this program. Triple. What is that? Triple. Target triple to disassemble for. Okay. Okay. Let's do minus version ZH. Register targets. There's a lot. x86. x86, yeah. Then we do triple. Target triple. Yeah. Okay, so we do disassemble all minus triple equals x86. Yeah. Then let's demangle all x86. Demangle. Okay, let's see. No. Unable to get targets. Oh. Oh. No, I don't know what to do then. C version and triple version. Minus version. Display the version of this program. I don't know what that means. Okay, well, we don't need the disassembler. It's okay. Let's try something else. Let's try just disassemble. How about that? Let's try disassemble. That also doesn't work. Okay. Then we try dwarf dynamic relog. Display the dynamic relocation entries in the file. Okay, let's see that. Dynamic relog. Dynamic minus relog. Dynamic minus relog. Okay, let's see what that gives. Nothing, it's empty. Dynamic relog. Okay, what about dynamic sims? Dynamic sims. Sims. That is also empty, and we have misspelled it. There we go. Also empty. Okay, so there are no dynamic symbols, relogs. Okay. Fault map section. Overall file header. File headers. Minus file headers. File headers. File minus headers. File minus headers. Let's see what that gives. It's also empty. Nothing in there. Full contents. Oh, let's go. Full minus contents. Full minus contents. And that gives something. Let's see. Oh, it just gives. Okay, well, that's not very useful, but okay. Okay. Whatever. What else do we have? Contents. Let's see. Use MachO specific object file parser. Use MachO object file parser. Okay. So what happens if we do here we do all headers demangle minus MachO. Would that change anything? MachO, let's see. Oh, I did a mistake. Let's do that, and then demangle MachO. There we go. Okay. Okay, so it creates this file. It has the same size, so I assume it's identical. Okay. MachO specific object file parser. Okay, what else do we have here? No debug info. No. Offloading. Okay. Private headers for specific. Relog. Okay, let's look for relog. Relog minus relog. There we go. Okay, there's something inside. Let's see. Okay, I don't know what that means. Vanilla ice cream. Okay. I don't know what that does. Relog. Good. Let's see. What else do we have? Relog. Okay, section headers. Display summaries of the headers. Summaries of the headers. Section headers. Okay. Section headers. Section minus headers. Relog. Section minus headers. Yeah. Let's see. Okay, there's not much in here. Okay. Section headers. Sections. Okay. Okay. What else do we have? Good. Let's see. Show all symbols. Display LMA column when dumping elf section. Display the symbol table. Add symbol description for disassembly. Okay. Okay, let's try sims. See if that gives any difference. Sims. Let's also do a demangle. Sims minus demangle. Okay, sims. Yeah, it has about the same size as this one, so it's probably just the same. Yeah. Symbol table. Yeah. It's probably just the same as this one here, but this one has a few more infos here at the top. Yeah. Architecture. So it prints everything here. Okay. So there must be two symbol tables then. So there's this, and there's the second one. Yeah. Oh. Okay. Okay, what else do we have? Trace back table. Unwind info. Display unwind information. Display the version of this program. Architecture. Okay. Bind. Display MachO binding info. Print the data encode table. Okay, so how about we do minus MachO minus universal minus headers. MachO universal headers. Okay, there's not much in there, but there is something. Doesn't look useful. Weak binding, weak binds. Weak minus binds. MachO. Weak minus binds. Okay, nothing. Okay, what else do we have? Did we already? Let's do indirect symbols. Let's see what this gives. Indirect minus symbols, right? Yeah, indirect symbols. Indirect minus symbols. By the way, we'll be right back. All right, we are back in business. Okay, what do we do next? So we have indirect symbols. Did we already dump it? Indirect MachO. Now we have dumped it. There we go. Okay, there's something in there. Indirect symbols. Okay. Indirect symbols. Local. Huh. Okay. Okay, what else? Info p-lists. Info minus p-lists. Info minus p-lists. It's empty. What else do we have? Exported symbols. Exports tree. Exports tree. Exports minus tree. Exports minus tree. Exports tree. Okay, it's nothing. Okay, yeah, I'm not sure if we can get more out of it than we already have in this all headers. Let's delete this one. This is duplicate. Full contents. Oh, this was useless. You can also delete that. That's not interesting. Yeah, but this one is very useful. Yeah. Let's see, is there anything else? Lazy bind. Okay, lazy bind we can look at. Lazy minus bind. MachO lazy minus binds. Lazy bind. There's also nothing in there. It's all empty. Okay. No. Data encode table. Data encode. Let's take a look at that. MachO data encode. Data encode. Data encode. Also empty. Okay. There seems to be there's no MachO specific info here. Data code. Chain fix-ups. I don't know. Binding info. Bind. Okay, let's look at binds. Bind. Also nothing. No. No, I think this pretty much it's the same stuff that we get through leaf. This data here. We get the sections. I don't know what that is. The relocations. Then we get a bunch of sections here. And then a symbol table. And the symbol table contains the most of the stuff that we will have to work with, right? Okay, so I guess we need to get a good understanding of what all these different things mean. But so far, to me, it looks like there should be enough information to so we have V tables. Yeah, so this is a pointer to a V table. We have type info. I don't know what this would be, but we can check what it means. Type info name. Type info. Yeah, that also links here to some address. Then we have a non-virtual thunk. I don't know what that means, but also has an address here. Yeah. Mm-hmm. 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 Yeah, yeah. Um, one question is, can we ignore all the PowerPC stuff and just focus on the Itanium portion of the executable? I think so. So for example, so this is the first symbol table, right? Here, symbol table. So this is the first one. Ugh. And so if we, okay, there's some Mac specific stuff, we don't care. Let's go down here. So here, for example, we have game engine init. And so there should be one here, and there should be another one in the other symbol table. Right? Yeah, here. There we go. Yeah. Mm-hmm. So my expectation is that we ignore the PowerPC portion and we just focus on this one. Yeah. Mm-hmm. Okay, so the way I understand it is that we need to, that the relationships between some symbols are dependent on their order, the order that they are sorted here in this list from top to bottom, from top to bottom. Yeah. So here, for example, we see that we have a message stream CPP, yeah, and that probably includes these two at least, and that's, yeah, that's probably this information, and then this function here belongs also to the CPP. I don't know why it has to list this twice. So why is this here when this is already here? This is, I don't understand. And this one here, this one is the size of this function. Yeah, the one that comes after. I don't know what this W means. Writable maybe. That can't be. It's a function. W. I don't know. Win. Okay, so I don't understand. I don't understand. Let's look somewhere else. It's hard. The problem is it doesn't demangle this, so it's hard to say what this means. It's AI reset. AI reset, yeah. And here is AI something, maybe a constructor or something, I don't know. Then I don't understand, like, okay, why is now this game memory.header, why is this at the top here? Like, I still don't fully understand the relationship between this guy, the function, and the file. Like, is this contained in the file that is right above it, or the one that is at the top of this block, or how does this work? I don't fully understand. Here we have some functions. So here we have IETN guards, guard machine, and I guess all these functions here belong to this one thing. Man, how does this work? I don't know. Maybe if we look at this long enough, we will understand. But right now, so certainly we have those in proximity, so they are related. That's what we can say, right? We have function here, locomotor is in here, move towards position, wheels, takes a physics behavior, right? So it's class locomotor and it's locomotor CPP. So certainly it belongs. But how do all these other headers relate to this? This is what I don't fully understand. If we could get some intel on this, I think it would be very useful. Because there must be some rationale behind this. And why does it say override.h so many times? And overridable as well. And locomotor as well. Why? Like, it takes all the space here, all this text, but what for? What is the reason for this? I don't understand. Okay, how about we take a small example? Yeah, how about we take this here? This. Yeah, this we take actually. Maybe the ones at the bottom belong together. Like this one, object.h, maybe still belongs to this. Maybe we need to, let's scroll down locomotor. Let's scroll down. Let's try to find an edge where locomotor ends. Here, locomotor set. Good. So here's locomotor. Still locomotor here. And then there's something. There's a locomotor set. Okay, no, that doesn't help. Let's keep on looking. Locomotor store. Oh. Okay, that doesn't help much. Okay, actually, let's do the following. Let's take this block. Let's take this block. Yeah, and then we just go to ChatGPT. There. Let's open a new chat. I have the following block of data from llvm-objdump of a MachO executable. What can you break down how the how the symbols relate to each other? I have a portion. I have a portion of I have a portion of data from llvm-objdump of a MachO executable. Can you break down how the symbols, how the listed symbols relate to each other in this sample? Okay, so we just drop this whole thing and then we ask. Let's see. The snippet provides information on symbols, their addresses, and the types. Key observation: addresses and symbol type. Each line starts with an address, which indicates where the symbol is set. This is not correct. Like, this is something else. This is not an address. These are primarily in the undefined section, which indicates these symbols are unresolved and must be resolved at link time or runtime. The D type indicates a debugging symbol, while W indicates a weak reference. Path and headers. Many symbols reference paths to files or headers. Yeah, I know. These entries suggest debugging information or metadata regarding source files that contribute to the final binary. The lines, these are mangled C++. Yeah, I know. Refers to the destructor. Okay. Refers to the base destructor of the same class. These symbols likely originate from the locomotor CPP file and are related to the functionality in that file. Yeah. Okay. I got to the same conclusion. Repetition. Some paths and headers appear multiple times. This could reflect multiple references to these files in different compilation units or location within the same binary. The trailing entries with addresses such as this are placeholders for symbols that are yet to be resolved. These empty names and low addresses suggest these might be dummy or placeholder entries. Is this correct? We did find out that the one behind this function is the size of the function. Maybe that's not always the case. I don't know. I wouldn't know what these then mean. Like, what does this one mean then? Locomotor template. Yeah. Key source file contributing to this binary and interacts with headers. Symbols are critical for handling destruction. Headers like this are used extensively, indicating their significance in the code base. This data suggests the binary includes detailed debugging information as evidenced by full paths to source files. The symbols allow tools like debuggers to map binary operations back to their corresponding source files. No, I don't. I would not like demangling, but I would like to understand what I would like to understand why header files and source files are listed multiple times. Is there any information how these file symbols are meant to be understood? In relation, meant to be understood in relation to other symbols, other symbol types nearby. Okay. The repeating list of headers and source files in blah blah output typically arises from how debugging symbols are structured and stored in the binary. Here's how you can understand. Repeated entries for headers and source files are part of the debugging information. They help tools like debuggers or profilers correlate machine instructions to the original source code. Each instance typically corresponds to a particular scope, module, or compilation unit where the file was referenced. Hold on. I think I understand now. I think, so as you can see, this one shares the same address, right? And this as well. So I think what this means is that the instructions at these addresses refer to code that comes from this file, like inlined information or like a function call or something that belongs to this file or this file, right? I think this is how this works. That makes sense. Okay, so for example, here we have a pretty big function, 3D4, and that's why we have all these different code pieces coming together in this function. So whereas here we have a shorter function, which is just 9 bytes, and that's why this one only has, yeah, it's very short, just has this one file listed here. Okay, that makes a lot of sense. Okay, but it doesn't give us line information. It just says it belongs to this file. That's curious, isn't it? That is curious. Well, I wonder, maybe there's some additional information embedded, which is not listed here, but which also says which line it is. Maybe. Yeah. Okay, so how would we go about using this then? So we have, so this one, it doesn't share EE20, EE. So it doesn't start at that, but we can say, okay, so we know we have this here, this, and this size, right? So we know that beginning from 20 up to this plus this, all these belong to this function. And then we need to figure out, okay, in which file is it actually? That's harder to say. Well, there is a CPP, so maybe the CPP should always take precedence. But what if there are only headers? So the function is that a thing? Can it be? Let's see. Let's just look through some more samples. Can there be any function where there's no CPP? I don't know. That's also peculiar. Static initialization, F. Static initialization. Maybe there's always one CPP in there. At least. Yeah. Okay, but we can absolutely work with that, yeah. I do wonder, is this useful, like, to maintain this list for any other purpose? Like, well, to know what needs to be included, yeah. Yeah. Okay, but I now understand how we build the relationships between files, include files in the CPPs, and yeah, where this function belongs. So this is pretty good. This is really, really good. Yeah, fantastic. This is fantastic. Yeah. I wonder, like, where does this path actually start? Does the path start at game engine or already at PC? Let me see. Let's search for users Kevin. That's a person who compiled this code. Let's search for this. And then we check. I assume that the path starts at game engine. It could be PC as well. Why is it a PC? He's working on macOS port. Oh, look at that. Okay, so 0 hour is the top folder. 0 hour. And then there's a Mac tools build. Okay, so the top folder is 0 hour. And there's also something in 0 hour. What is that? 0 hour. Oof. Hidden. Kappa utils. I don't know. Okay. It's interesting that there's o file dot o. Okay. PC libraries. PC libraries. Okay. So there's a game engine device folder as well. Game engine device. Game engine device, libraries, ww Vegas. Yeah, okay. Okay, cool. Okay. Yeah, fantastic. Fantastic. Now the question is, what is this here then? So this one is the size of the function. These are the code that belongs to the files inside this one function. But then what is this here? What is this? I don't know. Maybe we will learn more about this when we look into their flags or whatever they have. Type flags, bit flags, descriptions, whatever. Yeah, it's hard to say. It's also small numbers in various variations. I cannot really say what it is. It's only some functions that have it. 464D. There's also no system here, so this number is smaller than this. This is smaller again, so there's no like increment or anything like that. It's just some random numbers. They probably say something, but what would they say? I don't know. Here we have the same. There's one number here. Collide module is salvage crate collide. Let's search for this in Thyme actually. Let's see if this is already there. I think it's not. We probably don't have this collide crate. Collide module. I don't know. Collide module, actually we have it. Is salvage crate collide. Oops. Is salvage crate collide. There we go. We have a in Thyme there's a different naming convention, which is a mistake because it's not implemented yet. It's just a shell. Yeah, which is pretty much the same we want to do with code generation. Like, so when we generate the skeleton code, we want to generate pretty much things like this, but just for everything, right? To have it like everything correct. Unfortunately, we won't have access to return types, so these need to be placeholder, but yeah, that's okay. Okay, let's try to find some other than, then we must find something, I guess. What about leaflet? That's probably not in Thyme yet. Here, what about this? Oh no, it's crate again. Let's try to find something else. Here, OCL updates. What about this one? Reset timer. Let's see. OCL update is here. Reset timer. Reset. Do we have that? Reset timer. Looks like that function does not exist yet. It's also just a shell. Okay. Then the death names. The death names. Let's look at this one. Don't have it. Why do I always click there? It would be nice to find some sample. What about this one? Oof. Open contain. Get module name key. Oof. Open contain. I don't think we have this. No, we don't. Come on, I must find some sample here. here, Snow Manager. That one looks good. Snow Manager. I think we have this one. There we go. Snow Manager. Update any settings. Update. Oh boy. Ah, here. There we go. Okay, what is in there? Update any settings. I don't know how this would relate to anything. I don't know. Maybe it's line numbers? No, that can't be. No, or maybe? Could it be line numbers for something in here? But then why would only some have it and not others? I don't know. But then they should be closer together, right? Well, these are pretty close together. I don't know what it means. Okay, but we can figure it out another time, I guess. Okay, I'm very happy with what we have just discovered here. We have now an understanding of how functions and these files relate to each other, and this is great. This is good. Okay, cool. Yeah. What's the time? 1:22. Yeah, I think I will take a break now. Let's see if there's any space. Let me write an update here. I feel stupid. I feel stupid that it took so long. But after taking a good look at llvm-dump, object dump output for Mac, etc., I figured how file symbols relate to function symbols. With this, we can build file structure. File structure includes and function location. Good. Yeah. Then I will take a break now, and maybe next session we can look a bit more here. But my understanding is that there is no tool that will do the interpretation of the symbols for us. So we will implement this ourselves. We will build the classes. We will build where, in which header and CPP they are. We will build the inheritance. We will build the virtual functions and overrides and the statics and yeah, basically all the classes and its functions with inheritance and the files, and that's about it. And the statics, yeah. That should be the end goal. And anything else on top that we could find. But yeah, I certainly see this happening. We should be able to build the same. The only thing that will be missing from functions is a return type, because that is not part of the function name. So when we look at this, for example, here, as you can see, we do have an argument name, argument type, but we don't have a return type that's consistent for all functions. Let's try to look at some other functions. Unfortunately, they are all mangled still because of this codon F. But yeah, trust me on this. There is no return type. Yeah. So that means we need to have placeholder return types. Yeah. Yeah. Then we put some MachO, I don't know, unknown, something like that. Yeah. Okay. Good. It was a good session, I would say. Then next session, we keep looking at this a bit, and we look at the vtable ones and the type info ones, and yeah, try to get a bit of more understanding how some things relate. Yeah. Okay, cool. All right. Then I wish you a great day or night until next time. Goodbye.